file. An image is represented by an m times n integer grade image where image ij index value represents the pixel volume of the image. You are also given three integers sr, sc, and color. You should perform a flood fill on the image starting from the pixel image sr sc to perform a flood fill and considering the starting pixel plus any pixels connected for that directionally to the starting pixel of the same color as the starting pixel plus any pixels connected for directionally to those pixels also with the same color and so on. Replace all of the aforementioned pixels with color. Return the modified image after performing the flood fill. So let me copy this. So this is our example one. We have our image, integer grid, SR and SC. The starting value of the pixel, and color, which is the color that we will have to replace them with. So for example here, this is our starting index value. So we have to turn all of these that are connected four direction, left, right, or up, down, left, right, and they have to have the same value also. And then here it shows 2, which is our color that we painted all these values with. Since we can only go left, right, and up and down for directionally, we can't get to this one, so we just paint the image. One. That's our starting point. Okay, example 2, we have 0, 0, 0, 0, 0, 0, 0, 0. All of these values are 0, so I put that 0. Since the starting pixels are colored with 0, which is the same as the target color, therefore no changes can be made. So if let's keep this in mind. So let's get into this, solving this. So let's name image value our starting slash original pixel color. Let's call it original color and give it the value M, SR, and SC. Oops. And then so let's check if image SR. Let's say the starting point is equals to the color variable color. Then let's return the image. So now we have this case and this case. So whenever if we have any, so for example here, since our starting point is the same as the color, the value in the starting point is equals to the color, then boom, we just return our image. Let's make a DFS function. Let's call it DFS. The DFS helper function to traverse the grid and color appropriate values. So let's call it R and C, and let's make our check if inbound. If not, then stop going the direction. Also check if image SR. Let's see if check if current image is the same as our original color. So we will do that by doing len if C is less than 0 or C is greater than or equals to the len of image. So that basically means no, this should be, let's make this an R. So so the row is 1, 2, 3. Oh, 1, 2, 3. So we have to be, if they're not inbound, then let's stop going that direction. So the C will be also be the same format, but 0 or the column C is greater than or equals to the len of image and 0. That's all, 0. So this the column is 1, 2, 3. So 1, 2, 3. Or let's check if it's the same color. Image or C. The current image is equals to not equals to original color. And let's return. Boom. So now we check if we can return. If we make it past through this and we're able to go through if it doesn't meet any of these, then let's let's color our image grade src would now be equals to our color and then let's make our directions for directional assign color. Let me call it DFS recursively call DFS R plus negative -1 will take us C will take us down no down wait hold on up DFS R plus 1 with C will take us down DFS R C plus 1. This is a column. The movement of our columns will be right. These ones are easy. The column ones for most people because that's how we're used to seeing them. So R C -1 is left. Return image and let's call on the DFS function inside our so DFS SR and SC. So that should work perfectly. Let's see if there's any mistakes or syntax errors. Oops, found one already. Let's see if it's going to work. Boom, and it's been accepted. So our time and space complexities are time and space complexities are both in the worst case O of M times N and M is greater in time grade plus grade times row times column. So let me summate this to see if it's going to work for all cases, and it's been able to work for all cases. So that's it for this problem. It's one of the easy DFS problems.